This is for Year 12 methods. It comes out of Chapter 6. It's the extended answer of the review set. Question 27. A manufacturer produces cardboard boxes that have square ends and a rectangular base. The bottom of the box has a double layer of cardboard, so that's going to affect the surface area of cardboard, but it won't affect the volume. And each box must be able to contain 8. So the volume of each box is 8. Okay, find an expression for L in terms of W. Well, I know the volume of the box is going to be 8, and the volume is going to equal length times width times height, which in this particular case is W squared H. 8 equals W squared H. L in terms of, so that's L. L in terms of W, so L equals 8 on W squared is the answer to part A. Part B, find an expression for the area of the cardboard in terms of W. The area of the cardboard is going to be 3 lots of LWs because I have 2 bases and a top, plus 2 W squares for each ends, plus 2 more LWs for the sides. So it's 5 LWs plus 2 W squared is what the surface area is going to be, and it's got to be in terms of W. So it's going to equal 5 times 8 on W squared times W plus 2 W squared, which equals 40 on W plus 2 W squared, is an expression for the surface area. Sketch A against W. Okay, so I've opened up the class pad. I've got 40 on W plus 2W squared. I'll open up a window, drag and drop. There is what it looks like. So I have an asymptote happening. I'll ignore over here. So if I go analysis, G solve minimum, I get that there. So if I'm looking at a graph for me to draw, and the coordinates there will be 2.15, 27.85. That's surface area against the width. Part D, what length will minimise the amount of cardboard required? To minimise the amount of cardboard required, I would need to take dA, dW, set it equal to 0 and solve for W, and then find out what the length that is. So if I take this expression in a new line, select it, select it, 2D, calculate derivative with respect to x, set it equal to 0, and solve. X equals 2.15. I know that W length equals 8. Length equals 8 divided by x squared. Option given x equals that. That's the length 1.72. So the surface area will be minimized when length equals 1.72 meters.
And what is the minimum area required? The minimum area will be 27.85 meters squared. That's the minimum area that is needed of cardboard.